Hello, Mahendra. Before you start, can you please tell me the name of subject and the organization you are applying?
So the subject will be the heat transfer operation and the organization will be NITIE Bombay.
Okay. Okay, my first question to you, what is the difference between the study of thermodynamics and the heat transfer operation?
Sir, heat transfer will be a transfer of heat due to the temperature difference and it could be anything. And thermodynamics will deal with how this heat transfer is dealing with the physical systems.
Okay. Anything else?
And sir, in heat transfer will also determine the rate at which heat is being transferred. But in
Okay.
thermodynamics, we won't know the heat. We will only know the quantity.
Okay, good. Anything else?
Nothing.
Okay. Okay, what is the difference between natural convection and the forced convection?
Sir, in natural convection, basically the heat will be transferred only because of the density difference of the fluid. And in forced convection, some other impetus will be there, like blowing wind or any fan is on. So that will be the force, like the fan above me. It is being transferring my heat with the help of forced convection, not natural.
Okay. What is heat transfer coefficient?
So heat transfer coefficient will basically give us an idea about how fast heat can be transferred through a medium. If it is high, that means heat will be transferred very easily.
Okay. And what is the difference between heat transfer coefficient and thermal conductivity?
Heat transfer coefficient and thermal conductivity. Sir, I am forgetting about it. I have to revise that.
Okay. What is the significance of heat transfer coefficient? Any major significance?
Sir, basically that only we'll know how fast the heat transfer can happen through it.
Okay.
Higher the heat transfer coefficient means that material is far more conductive.
Okay, it is a fluid property.
Uh, what sir? I didn't get the question.
Is heat transfer coefficient is a fluid property?
Fluid property. Yes, sir.
So it only depends on the nature of fluid.
Sir, it will depend upon the nature, composition, surface, area.
Okay. Okay, what is thermal boundary layer?
So at the thermal boundary layer is the locus of all the points where the temperature is equal to the 99.99 into the surrounding temperature.
Okay. Anything else?
No, sir.
Okay, name some important types of temperature measuring devices.
Okay. So one will be the thermometer and
Okay.
so devices names I'm not revised. That's why I can't get right.
Okay. Have you seen thermocouples?
Yes, sir. I've seen thermocouples. So it will be basically based on the Seebeck effect. That means if we have two conductors with different conductivity joined together, and at the sides of the both conductor, if we are providing temperature difference, and so these two conductors, since they have different conductivity, so there will be a EMF generated between them because of the difference of conductivity. So we'll measure that EMF, and based on that EMF, we'll get the temperature.
Okay. What is superheater?
Superheater.
Yes.
So superheater will basically, suppose if steam superheater is there, that means it will heat our steam above the saturation temperature. Like if we have to heat the steam above 100 degrees, that means we'll use the superheater.
Okay. And what is degree of superheat?
So degree of superheat will be the difference between the saturation temperature and the current temperature it is available.
Okay. And what about the pressure?
Uh, like pressure in what terms?
During degree of superheat or superheated in superheater, what about the effect of pressure? Does pressure decreases or increases or remain constant?
So pressure should increase.
Pressure should increase. Okay. Okay. What are the reasons for insulating various equipments or various lines? What are the reasons?
So suppose like we have reactors in our company. So if in my reactor the, the reaction is happening at 500 degrees Celsius, and that it is very temperature sensitive. But
Okay.
if that reactor is not insulated, that means we'll lose some heat to the surrounding, because surrounding temperature is very low, around 20, 30 degree, 40 degree. So
Okay.
that will change the reaction temperature, and which will in turn change the quality of the products which we are getting.
Okay.
So to minimize that losses, we'll insulate the reactor or pipes or any other.
Any other reasons?
Any other reason?
Only one reason.
One thing is to minimize the heat losses, and other thing.
What kind of reactor you are working with?
Sir, I'm currently in FCCU, so it is a fluidized catalytic reactor.
Okay. Why fluidized catalytic reactor, not fixed bed?
Sir, basically because of the contact, because it will enhance the contact area and the contact time between the catalyst and the feed. So basically the reaction will be much faster, and the conversion will be much better than the fixed bed.
Okay. Anything else?
No, sir, not that I can think of.
What is the reaction time in FCC?
It is 1.8 seconds.
You people are operating in 1.8 seconds.
Yes, sir, 1.8 seconds, around 200 tons of feed.
Okay. Okay. Now, under what circumstances overall heat transfer coefficient will be equal to the individual film coefficient?
Sir, if there is no fouling resistance, or the
Okay.
internal heat transfer coefficient and the external heat transfer coefficients are similar, in that
Okay.
condition we can say that overall and individual heat transfer coefficients are equal.
Okay. Anything else?
No, sir, not that I can think of.
Okay. What will be the effect of vibrations and pulsations on heat transfer coefficients?
On heat transfer coefficient, sir, if vibrations are increasing, Sir, for a metal, if I'm correct, if we increase the heat, that means that conductivity decreases because there are so much vibration increases and the losses also increases.
Okay. Okay. So let me give you the feedback.
Yes, sir.
Okay. So about superheater, you need to study about the superheater.
Huh.
Okay. And what is
Okay.
degree of superheat?
Mm.
Heating above the saturation temperature at same pressure. The pressure will not change. Only the
Oh, okay.
temperature will. Okay.
Okay.
And study about few types of temperature measuring devices.
Yes,
Okay.
yes.
Along with its principle.
Huh. Correct.
Okay.
Huh.
Whether it is thermocouples or resistance temperature detectors or
Hmm.
thermostat, because you are a working person, right?
Working profession.
So
Yes, yes. Correct.
you should know all about this.
Yes.
Okay, because you are looking after those equipments.
Yes, sir.
Okay, and about insulating plants and equipments.
Hmm.
So there are various reasons. We are not just uh, reducing the
Yes,
heat
yes.
losses.
Hmm. Hmm,
There
hmm.
may be to maintain the certain process temperature parameters. Okay, to prevent
Okay.
from condensation. Okay,
Hmm.
to protect equipment from corrosion.
Yes, sir.
Okay, to provide fire protection to the site personnel.
Hmm. Correct.
Okay, so they are the various reasons.
Hmm. Hmm.
And about the effect of vibrations and pulsations on heat transfer
Hmm.
coefficient.
Yes, sir.
So if vibrations and pulsations will occur, so
Hmm.
ultimately it will create turbulence, right?
Huh.
So in turbulence, the heat transfer coefficient will be high. So heat transfer rate will be high.
Okay.
Okay, very simple. You don't need to, and you are correlating with thermal
Conduct.
conductivity.
Huh.
There is
Huh.
no scene of thermal conductivity here.
Okay.
Yeah.
Okay.
The question is simple. Don't try to like complicate those things.
Huh. Huh. Correct.
Okay. And about overall heat transfer coefficient and individual film coefficient. So
Hmm.
when one of the film coefficient is very large as compared to the other one
Huh.
or other
Correct.
resistances.
Hmm.
Okay. So generally what happens? Generally 1 by UA equals to 1 by HIAI plus 1 by
Hmm.
S naught again N naught.
Hmm. Hmm. Hmm.
Considering all the resistances are negligible.
Yes, yes.
Okay. So if HI is very much larger than S naught, so 1 by HI will
Huh.
be negligible.
Yes. Correct.
Okay. So
Hmm.
ultimately the U equals to S naught. Okay. So that is the case where the overall transfer coefficient will be equal to
Equal to
individual
individual.
individual
Correct.
film coefficient. Okay.
Yes.